Hello student. So let us start our discussion. In previous tutorial or in previous video we have discussed what is subroutine, and then we have tried to implement a subroutine which will perform the shift operation for 4 times, and then we have discussed that how it can be useful in input output process. So here we will discuss another part of subroutine, that is parameter linkage. Okay, means how parameter means argument can be passed into the subroutine. So here we will try to implement this program. In this program we will try to implement x or y. Okay, using De Morgan's theorem, that is x dash dot y dash and then all dash. Okay, so this is what we are going to implement. Now let us start. The origin starting of this program is 200. Okay, so from 200 onwards all the instruction will start. What is the first instruction? Load a with the value of x. Okay, so let's say what is value of x? 7b95. Okay, so right now in accumulator there is 7b95. okay, then what is the next instruction? BSA or. Okay, so it will jump branch and save return address to 207. Now while this instruction is being executed, what will be the value of program counter? 202. Okay, so on this hex 0, 202 will be stored. Clear with this? Okay, now let's start our execution from here. So what is the first instruction on 208? CMA. Okay, so SE will be complemented and then store it on temp. So on temp we will have SE complement. Okay, what is inside SE? It is X. What is inside SE? X. Okay, so in temp we will have X dash. Then what is next? LDA or I. Okay, so here what is meaning? Load accumulator where address will be specified symbolic address or using indirect addressing mode. Okay, so it will go to location 207, then on that location 202 will be stored, so then it will go to 202 and whatever value is there it will be loaded into accumulator. So new content in accumulator is 3A F6. 3A F6. Okay, next is complement. So SE will be complemented. Next STA temp, complement, then end temp. Okay, so in temp we are having value X dash. Okay, in SE currently we are having value, this is Y, variable Y, so Y dash. So then end will be performed, so SE and TMP. Okay, TMP is nothing but we can say X dash. So here in temp there will be X dash, so Y dash dot X dash, that operation will be performed. Next instruction is CMA, so again Y dash dot X dash, it will be complemented. Okay, and then IZ or. Okay, now what is meaning of this? IZ or, here what is the value on IZ or 202. Okay, so it will be incremented to 203. Okay, so means we are done with the usage of this operand. Now we will store result. So then BUN or I. Okay, so branch unconditional or using indirect addressing mode. So current value of this location is 203, so the execution will be transferred to this instruction, that is STAY, store accumulator on Y. So currently Y is empty, so whatever answer we will get for performing this operation, okay, it will be stored on this location. Okay, and then execution will be stopped. Okay, so here you can see we have not passed any argument we have not passed multiple argument to function. Okay, so how we will pass argument, single argument to function? We will store one variable into accumulator, let's say 7b95. Okay, and then we will call the function. Okay, so inside that subroutine we will directly use that value. So this is the one way that we can pass the argument using accumulator to subroutine. Now let's have a look at the another program. Here in this program we will try to focus on how block of data can be moved from one place to another place, or it can be copied from one place to another place. So let's start our discussion here. Let me tell you that how many portions this program will be divided. So this program will be divided into these three parts. So this part will provide the initial address, then this part will provide the initialization of all the variable memory word which we are going to use throughout the program, and this will be the loop, okay, which will help us to transfer data from one place to another place, or from source to destination. Okay, so here hex 100, it is the starting address for source. Okay, then next is destination 200, so it is the destination address, and this is the program where we are where we have this is the location where we have stored all this program. Now next is decimal minus 16, so that is nothing but counter, that how many word of memory we want to move from, or we want to copy from one place to another place. Okay, so let us start. What is the first instruction? org 400. So the origin of program will be specified on memory location 400. Then BSA MBE, so branch and save return address move. Now whenever we will branch to this location, return address, what is the return address? Let's say this is 40, then 401, 402, 403, 404. Okay, so what will be the return address? Return address will be 401, so that will be stored into MVE 401. Okay, why? Because while this instruction is being executed, program counter will point towards the next location. So current value of program counter will be stored on the first memory location of subroutine. Now what is the first instruction? LDA load MVEI. Okay, so what is content on MVE 401? So there is indirect addressing mode, so we will go to location 401, and then what is the value? 100. Okay, so that will be loaded into accumulator register. Okay, so let me take accumulator register. So 401 100 will be loaded into the accumulator. Then STA-PT1. Okay, so this 100 value means this starting address will be stored into pointer 100. Then what is next? ISZ MVE. So 401 will be incremented, okay, and new value will become 402. Then LDA MVEI. So LDA MVE 402, and what is value of on location 402? 200. So new value will be loaded in the accumulator, that will be 200. Now then STA PT2, so this 200 will be stored into PT2, pointer 2. Okay, then ISZ MBE means increment the MBE, so this 402 will become 403. Okay, and then LDA MVEI, so minus 16, it will be converted into 2's complement, this will be converted into 2's complement format, and then it will be loaded into counter. Okay, so just for understanding, for ease of understanding, we will keep this in decimal. Okay, so then ISZ MV load MVAI, so minus 16 will be loaded, which is on location 403. Okay, then STA CTR, so this minus 16 will be stored into the CTR counter. Okay, and then ISZ MVE. Okay, so again this MVE will be incremented, so this will become 404. Okay, so here you can see while we are done with while we were initializing the memory word for data transfer, at the same time we have used this variable. Okay, and whenever there will be mm, you can say completion of the subroutine, okay, then execution will resume on memory location 404, which is pointed by MVE. Okay, so let's go to the next statement, LDA PT1I. So load accumulator PT1. What is value of PT1? 100. So it will go to memory location 100, and whatever operand is there, it will be loaded into the accumulator. Let's say that value of operand is 1. Okay, so here 1 2 3, let's say 16. Similarly here it will be empty, so 1 will be loaded. Then STA PT2I, what is the value of PT2? 200. So this one will be copied into this memory location. Then means accumulator will be stored on this location. Then what is next? ISZ PT1. So the new value of PT1 will be 101, and the ISZ PT2. So new value of PT2 will be 201. Then ISZ CTR. So this will be incremented and it will become minus 15. Clear? Okay. Then BU and LOP. Okay, while we will increment counter, we will check if it is 0, then we will complete the execution. If it is not 0, then we will go to the loop. Then LDA PT1I. So what is value of PT1? 101. So it will go to memory location 101. What is the value of operand? 2. So 2 will be loaded into accumulator. And then STA PT2I. So what is value of PT2? 201. So these two accumulator will be stored on memory location 202. Sorry, 201. Okay, and so this will be stored on memory location 201. Then ISZ PT2 and ISZ PT1. So this will be incremented to 102. Then this will be incremented to 202. Okay, after that ISZ counter. So counter will be incremented minus 14. Okay, so we have successfully transferred the two memory word from source to we have successfully copied the two memory word from source to destination. Okay, so similarly let's go with one more cycle. Okay, and then execution will continue like that only. So let's say 101 102 and last memory location is 115. 215. Okay, so this is the last memory location 115. So rather than we will say this is 10F. Here last instruction will be 20F. Okay, so here also there will be change. This is I have written decimal, so 10F and 20F. Okay, so this is the last instruction. Value of counter will be let's say minus 1. So LDA PT1. So value of PT1 is 10F. So 16 will be loaded into accumulator. Then STA PT2 means this 16 will be stored on last location in destination. Okay, then ISZ PT1 and PT2. So the new location will be let's say 110 and 210. Okay, after that next is ISZ counter. Okay, so counter will be incremented to 0. Okay, so increment the memory word and skip the next instruction if it is 0. Okay, so what is current value of counter? Value of counter is 0. So next instruction will be skipped and it will execute this instruction, that is BUN MVEI. So branch MVE. So what is current value of MV? 404. So then again it will go to this location, and rather than jumping to only MV from using indirect addressing mode, it will jump to last instruction, that is halt. Okay, so this loop will be executed, let's say 16 times. Okay, this initialization will be done one time, and this won't be, means this memory locations won't be used for instruction. Okay, so this will be used for data storage. So till now whatever we have seen that whatever we have discussed, okay, in that we have seen that normally we will write data at the end of the program. Okay, but it is not the way. We can also write data in between the program. Here you can see in this example we have passed only one value into the argument. Okay, but here we will pass the starting address of all the variable, and then we can access n number of variable which are stored sequentially. Okay, so this is how you can pass multiple values to subroutine function. Okay, so in this tutorial we will keep up to this. In next tutorial we will start our discussion with input output programming. Thank you.